Hi, what's up guys? Today let's look at the Lintcode problem number 10, String Permutation 2. This problem actually is very classic and is very interesting. So let's look at this one. What we're going to do is that we were given a string and we need to find all the permutations of it without duplicates. So this is kind of complicated because we have to deal with the duplicates thing. For example, we're given a string A, B, B, and we have three combinations, A, B, 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 A, B, and B, B, A. And this one is the same. So basically, its meaning is pretty simple. We just need to figure out all the different permutations and also get rid of the duplicates. So how we're gonna just resolve this problem? I have two solutions. But today we're gonna just only focus on the solution 2 because this one is easier to understand, and it's simpler. This one I use a DFS search, depth first search. So let's look at the code. How we're gonna do this. This is our entrance of this code, String Permutations 2, and we were given a parameter string. And first step, all the time you have to check your input parameters, especially when you do the interviews. You have to show the interviewers that you have a sense of parameter checking validation. So if the string is null or empty, we just return a empty list. Then if the string is good, then we create the result list. We use this to collect all the results. And because the given parameter is the string, so we want to convert it to a list so that we have better APIs to manipulate the string elements. And also we have to sort this given string, because during this permutation calculation process we have some duplicates. If we just sort this, so it's going to be easier for us to detect the duplicates and skip the duplicates. And we have a DFS, a recursive call. So DFS is going to take this sorted string and take this take a list. Actually, this list is the for DFS to collect the local solutions. And once this DFS is done, actually, our result is done. DFS actually is going to just calculate all the permutations of the given string S and put it into the global variable self.result. And after DFS is done, we actually this result is going to full of the answers, and we just sort it and return. So actually, our core part is going to be the DFS. During the interview, you'd better just split into different functions, so to make it simple. So our core is in this DFS. DFS is a recursive call. What this call does, like I mentioned before, the call is going to calculate the given strings, all the permutations without duplicates, and put them into the global variable self.result. Because this is a recursive call, so first things first, we need to think of how can we get out of this recursive call. That is, we need to specify the termination condition. So that your recursive call is not going to just run forever. The termination condition in our case is that if the string is null or empty, that means we don't have to do any further calculations anymore. So we just put this local variable, local solutions permutation, and put this permutation into this global parameter self.result. And we need to notice that this permutation is a list. It's the local variable. So when we append things to our result, we don't want to hold this reference. We want to just clone a new one. So in Python, to clone a new one, we use permutation, square brackets, and with colon, That's the clone list. Correct? So if it is not, the string is not empty, then for a given string, how we calculate this string's order permutations? For the strategy, how we do this, we need to pick one from this string, right? From this array, we need to pick one. We pick different ones. It's going to be different permutation. So pick different ones is gonna create different answers. In our DFS, we're gonna just try every possible solution. So we use the for, and we for each element, and we try to pick each element as the first one. So we pick that and we remove it from the current string. We pop it out and we put this string into the permutation. We got a sequence. Then after this is done, then we're gonna just need to do the same thing for the remaining string. We need to pick another one from the remaining string and continue calculating or working on this permutation thing. Once we try this, we need to recover. We need to try some other elements. So here we need to do a backtracking. So in our algorithm, we call it backtracking. Because we changed the local variable permutation, we changed the local variable string, so we have to recover what we did. For the permutation, we add this element into permutation variable. So here we just populate it out. Then we backtrack this one. And also for string, we populate it out, and now we have to insert it back. Just pretend nothing happened. Computer is good at doing this kind of thing. We try every solutions, then we come back and we just try the second solutions. So this is the whole concept, whole idea of this DFS search. DFS is gonna just try every solutions and calculate the string permutations and put them into the global result. One last thing we still haven't explained is that how are we gonna deal with this duplicates thing? Because before we send this string to this DFS, we sorted this string, and sort is gonna help us to do the duplication thing. So when we try to pick different elements and put them into the permutation variable, we have to do a check if the current one is equals to previous one. For example, we choose A, we put A into the permutation table, and we want to try the second element, but the second element is still the A, so it does not make any difference. So here we're gonna just skip. Yeah. So generally speaking, for duplicates detection, we did two things. One is we sort. The second one is that we check the current elements, what we choose, if it is equals to the previous one. If it is, we just skip. So that's the whole idea. So let's just run this. All right, so still taking a lot of time. Come on. All right, so looks like everything is right. So that's today's algorithm. This is really good good problem. So a lot of companies, when they love giving this problem to the candidates. So take your time and focus on this and practice several times. Thanks. Have a good one. Bye bye.